All right, gang, Math5130. The purpose of this video is to statistically describe a categorical variable. And you can see in the data set that I have in StatCrunch and in R, because I'm going to demonstrate both because it's going to be a brief video, how we statistically describe with each. If we're going to statistically describe arsenic, which is a quantitative variable, what do? Well, we look at a histogram, look at a box plot to identify outliers. Again, the histogram is for distribution shape, report the mean and the median, report the standard deviation, quartiles, and the things we talked about in previous videos. Things are a little different with categorical variables because you can't report a mean. You can't add them up and divide by, 71 or however many states there are. So the solution is pretty simple. First of all, there are two graphs that we use for categorical variable. One of them is called a bar chart, and in StatCrunch it's called bar plot. So I come over with data because I have data. Choose state, hit compute, and you'll see that I have a bar plot. Now, a bar chart is kind of like a histogram, except the bars don't touch, and there's no natural ordering of the cases, or I'm sorry, of the levels. It's got Arkansas first, California second, and Texas third because it's put them in alphabetical order. It doesn't always work this way, but again, there's no reason to have Arkansas first other than if we order these alphabetically. Something else another graph that we look at with categorical variable is called a pie chart. A pie chart. So with data, select state, hit compute, and it gives a nice pie chart. So with the pie chart, it's kind of nice because it represents according to colors, and it gives us the frequency. So we have 27 cases from Arkansas, that's 38.03%, California 28, and so on and so forth. If we don't have the pie chart or the bar chart, and we just want to look at frequency, we can go to table, go to frequency, select state, select frequency and relative frequency, hit compute, and we get the frequency and we get the relative frequency. So really, really easy to do. Now the fun part of, I don't know about fun, but the part of categorical variables that I would say becomes a little bit more challenging is when we start looking at like arsenic over state. In other words, is there any difference in the arsenic levels between California, Arkansas, and Texas? So that gets us into something called ANOVA, analysis of variance, but I'll teach that to you at the proper time. All right. Things are a little bit different in R. To find these values, what I would first need to do is I need to make sure that state is actually being recognized by R as a categorical variable. So what I can do is run the command isFactor. Now if this comes back true, then R is recognizing state as a categorical variable. If it comes back false, then R is not recognizing state as it should. Well, it came back false, so R is not recognizing state as a categorical variable, and we need to force that. So what I would do is I would just keep the name the same as state. I would force state as a factor. So what's happening over here is I'm forcing state to be a factor, and I'm just naming it as state. Now I can see if the new state is a factor, and it's going to be true because it's now recognizing state as a factor. That's really critical that you do this in R to make sure that R is recognizing, in this case, state as a categorical variable. Gosh, I'm losing my voice. So the first thing I'd probably want to do is look at a pie chart and a bar chart. R is a little strange here. What we have to do is we have to create a table using the table command for the variable state. From there, I can use pi of the table to get a pie chart. I don't like this pie chart as much as I do the one from StatCrunch, but nevertheless, if you're stuck on a deserted island and all you have is R and you need a pie chart to get off, here you go. To get a bar chart, we just use bar plot. Again, we have to use the table command result to do that. And again, there's nothing really too attractive about this, but it is what it is. I don't think this is actually, although it's in alphabetical order, I don't think it, well, I don't know. I don't know how it arranges it. Actually, it looks like it does. If we want to do frequencies, all I have to do is just take a look at the table. And we can see we have 27, the frequency of 27, what are we measuring here? Arsenic measurements came from Arkansas, 28 California, and 16 Texas. If we want to do the relative frequency, we just use what's called prop table. And again, use table, and we can see that these relative frequencies align with what we have from StatCrunch. So just two different statistical software packages to do the same thing. Well, guys, I can't make this hard if I tried. I will never try to make it hard. I always seek to try to make statistics easy. I hope by the time you complete this class with me, you feel that way. I guess the jury will be out on that one. So this will just about conclude the first lesson. There will be probably one, maybe two more videos where I will teach you how to write up the descriptive statistics for a data set. So that's all I got. Take care.